Next speaker is from NCAT. Please welcome Adriana Vargas Nordbeck.
Good afternoon. Like Ben said, I'm going to continue with the idea and show you more specifically the study findings for our preservation study and present not only the sections from NCAT in the southern half of the experiment, but also the northern part. So for those of you who are not familiar with our project, I'll give you a little bit of background. The timeline, it all started in 2012. Basically, one of the research cycles that NCAT goes through, they were getting ready to decide what wanted to be studied this time, and the general consensus was, well, let's look at pavement preservation. In the summer and fall of 2012, the first sections were built. These were on a low-volume road, county road in Alabama, Lee Road 159, for those of you who have heard of it. Following that, some of sections were constructed also in the test track in 2014, but the test track is more of an accelerated pavement testing type of facility, so there was that factor in there that also had to be considered. The decision to partner with Main Road in 2015 also helped expand the experiment and started building more sections in different places. So in 2015, basically the same amount of treatments were replicated, taken, even expanded a little bit, and built into a higher traffic setting. So that's Highway US 280, also in Alabama, close to Auburn. And then building on that, we've gotten a lot of good results, a lot of good feedback, a lot of support from our sponsors. So the northern sections were built in 2016. And again, it was pretty much taken what was already built in the south and taking all of that to the north and see how that behaves in colder weather. Now for 2019, as Ben mentioned, we're entering phase 2 of the study. So it's more like just a continuing of data collection, monitoring, analysis, but also the construction of those cold recycled sections on 70th Street that Ben just talked about. And like he said, we had same group of contractors, same crews even. So we've minimized some of the variability that goes into the experiment by isolating those factors. We have a lot of treatments, so anything ranging from crack seal to thin overlays and everything in between. A lot of combinations of treatments also, and pretty much anything you could think of and wanted to learn more about, we have in there. So we have a range of surface treatments, all kinds of seals, fog seals, chip seals, scrub seals, microsurfacing combinations. We have the cold recycling sections with a 1-inch thin overlay on top, and that includes CIR, CCPR, and now for the northern sections, SFDR. And then thin overlays that are 3/4 of an inch in thickness, very fine mixes. We have dense graded as well as OGFCs, ultra-thin bonded wearing courses, and also combinations of those, so we may have like a chip seal and then a thin overlay on top, or that type of combination in there. Ben showed you a table of what we do for measuring performance on a regular basis, and he showed you a lot of different indicators that we collect. But there are 3 that we keep a close eye on because we feel like those give us the best overall picture of performance for the sections. And the decision to do that was just basically take the MAP 21 criteria that is common to all of our sponsors, or at least our DOT sponsors, and look at that. Because if we wanted to look at, for example, a condition index, every state does their own thing. So MAP 21 was the one language that they all had in common. So we look at cracking, rutting, and IRI, and take that as our guidance for overall performance. But again, we also look at things like friction, FWD measurements to look at structural condition of the pavement, and noise, for example. So we want to look at everything, but these 3 are the ones that we kind of follow more closely. So now going into the results and what we have seen so far, and I'm just going to break this up into groups of different sections with similar treatment types. So let's take, for example, of all of our chip seals. We have single chip seals, single layer. Then we have the single layer with crack sealing. We have double and triple layers, scrub seals, and also a fiber mat chip seal. So all of those are put into that chip seal group. And if we look at the condition right now, and we have to remember these have different ages. So if we go in that table from left to right, the Lee Road 159 sections are now 7 years old. We haven't done anything to them aside from what was done 7 years ago. Then the US 280 are 4 years old, and then the CASA 8 and US 169, which are the northern sections, are 3 years old right now. So we have to keep that in mind. As expected, the untreated sections that are the oldest are already now in the poor category. They have more than 20% cracking. Some of the chip seals have gone into the fair category, meaning 5 to 20% cracking. In 7 years, I don't think that's bad. I think that's a good result. Some of them are even managing to stay in the good condition. And for the newer sections, most of them in the good condition, so less than 5% cracking. I think that's a very good sign. If we look at rutting, we didn't really have a rutting problem with most of these to start with. And the ones where we do see a little bit more deterioration in that part will be the US 280, the higher volume in the south. I mean, more rutting and the higher volume with hotter climate. I think that's expected. So I think we do see results that make sense. And now for roughness, our Lee Road sections, which are the oldest, they have managed to have good ride quality after 7 years. And then we see some of them that are mid-ground, a fair category, especially the CASA 8, the low volume sections on Minnesota. Now it's interesting to see that we have more yellow going towards that right side. That's higher IRI in the north. If you want to take a guess what that would be, well, they have really aggressive thermal cracking. So every time we hit those cracks, we have some bumps and some bouncing in there. So that could be important, and it will just determine the performance for the sections. Now, I selected some of these because we don't have time to go through all of them one by one, but for example, if we look at the chip seals, single layer, the ones on top of the north, the ones in the bottom are the south. The left is the low volume traffic, and then the right is the high traffic. So you can see overall they have a pretty decent cracking performance, good to fair. We have, like I said, more problems with roughness in the north because of those cracks. But then something that should be noted, the loss of chips in the northern sections. And again, that's a very particular issue to them due to snow plowing operations. So they lose chips because of that, which is not a problem for us in the south. We did try the triple chip seals, and we had better chip retention with those. But then we have another problem now. We have bleeding in almost all the sections, even north and south, as you can see. Now, balancing act. We fixed one thing and then maybe created another problem. But again, we have good cracking performance. Everything else looked good. We have to keep an eye on this for friction. If it becomes a problem, a safety issue, then it has to be fixed no matter how well it's doing in all the other indicators. Fibermat chip seal, and for those of you not familiar with that, it's just a fiber membrane, basically sandwiched between two shots of emulsion. And that seemed to help a lot with that chip loss. And it had a little better cracking performance compared to just a single layer conventional chip seal. So that could be another way to go if we wanted to still do chip seals in the north. Now, moving on to microsurfacing. Again, let's remember the Lee Road sections, the first sections that were built, that first column in there, are the oldest sections, so they're 7 years old right now. We have a couple of those that have fallen into the poor category, just barely right now. But it's basically the single layers. So we got good performance if we have 2 layers or if we have a combination of different treatments. So it can be a successful type of approach. On US 280, they're now in the fair range. And then the northern sections, which are more recent sections, they don't have a problem with cracking at this point. As far as rutting, almost everything is in the good category, and the exception is some of the sections, or maybe most of the sections on US 280, so the higher traffic, hot climate, a little bit more rutting, which again, I think would be expected. And for roughness, we have some issues with roughness, again, on that county road in Minnesota, especially, and then some of the sections on 280. Now, going back to those pictures, the 4-in-1 type of shot, you can see, for example, that lower left corner is one of the single microsurfaces with crack sealing. So that's one of the ones that went in the red condition category, more than 20% cracking. But if you look at the picture, it's very low severity cracking, very fine cracks, so it's done a good job at least keeping it tight. You can see the other sections in there. Even that US 280 in the right lower corner has some cracking along the wheel pads, but it's not really visible from that picture. So I think that's good. Even though it's there, it's very fine, and it may be still doing a very good job at preventing water from entering the pavement structure. Now, the double microsurface has done a very good job at basically reducing the amount of cracking that could come back to the surface. So that could be a very good option if we just want to enhance or even give us more pavement life, 2 layers instead of 1. It's still working very good. Some of the combinations, for example, this microsurface surface on top of a scrub seal has also shown excellent performance. So when we combine 2 treatments, we get more and more benefit. Again, now it becomes a matter of cost benefit, how effective that is for the price. But for example, for our Lee Road section, that pavement looks good as new right now, that microsurface on top of a scrub seal. Now, finally, going into the thin overlays, again, we have a lot of different sections that fall into this category, and not all of them are in all 4 places. But we see, even with a more robust type of treatment, you could get more cracking if you don't optimize the design of the mix. So in this case, we have 2 sections that we did a thin overlay, and we still ended up with more than 20% cracking right now at 7 years. And it's because we use 50% RAP in one and 5% RAS in the other. So a lot of recycled material, a lot of H material, stiffer mixes, they crack more. That was not the case for other HMA thin overlays that we placed. So we've seen very good performance from most of them. Rutting, not really an issue in any of them. And then we see more issues with right quality. This is a little more interesting because it doesn't follow that trend that we've been seeing throughout the other indicators, but we get more roughness in that Lee Road site. And what's happening there, every other side, we did some micromilling just to bring the pavement back to grade. In this case, we didn't, just paved that extra 3/4 of an inch. So when we're measuring IRI, there's a little bump in there. When we hit those sections going from the transition from the surface treatments to the thin overlays. And so there's some bouncing going on, and the IRI values are routinely high, but it doesn't mean it's not good right quality, if that makes any sense. So we keep track not only of the number, but also how it changes over time. So if those IRI values are in the third category, but still very constant, we feel very confident that this is a good treatment for that particular section. Now, looking at a couple of those that we have across all 4 sites, we have a virgin thin lay in all the 4 locations, and we've seen very good performance for cracking especially. One thing that we should note is that it has cracked in the north, but it reduced the severity of those cracks. So when it's reflecting those thermal cracks that they have in Minnesota, maybe you can see it in that top left corner. One of the lanes, you can definitely see that thermal crack, and then when we go into the treated section, it doesn't really look that bad anymore. So it's helped, and it's improved the right quality on the sections. Now, the ultra-thin bonded is another of the treatments that it's at all 4 locations, and it's been doing very well, but we did have a problem on Lee Road, again, Alabama, lower traffic, and we did have to fix it, repair it. So you can see the patch on that lower corner picture. And it's basically, we have a little bit of a hill in there, approaching the intersection, trucks are braking because that takes traffic to a quarry and an asphalt plant. So it caused some slippage issues, and we had to repair it at some point. In all the other sections, it's been performing very well, so we don't feel like we should punish it because it failed in that particular lane. You can see the other lane was also treated, and it didn't fail. So to summarize all of this, we think all of these treatments, pavement preservation in general, is a very good cost-effective strategy to extend the pavement life. We still have some questions about the life-extending benefits, and that's exactly what we're trying to answer with our project. And one thing that's important is to know that the benefits will be directly related to the condition of the pavement at the time of treatment. So if you wait too long and your pavement is in poor condition, don't expect to get as much benefit as if you do the work early when you have good pavements. Some of the ongoing work, well, we're taking that initial condition, take that as a variable, and look at the performance of the pavements depending on where you were at the time of treatment. So some of the curves that we have been able to generate, something like that you can see there on the screen. The solid lines are the measurements of the treated pavements, and then the dotted lines, or dashed lines, it's a projection of an untreated pavement that was in similar condition at the time of treatment. So we can measure the benefit in different ways. For example, let's take the fair condition category, a pavement that was treated when it was in fair condition category. This particular graphic is for cracking, but we could do it for other indicators. So for example, if you look at fair, as far as, well, how long did it take to go back to initial condition? In this case, we have about 2.5 years for a fair pavement in pretreatment condition. And we could also look in the vertical direction and look at the difference in cracking between a treated pavement and an untreated pavement, and that is also a benefit at any point in time. So again, taking some of the sections that we have, not many of them have gotten to the point of falling into the poor condition category. But for some of them, we have seen, for example, we could be 2-3 years before the section goes into poor condition category, maybe 6, 5, even 7. Most of them are still going strong, so more than 7 years of benefit in our case. If we look at crack reduction, and this is for the oldest pavements, I should point out, those in Lee Road, at year 7, we see a number of benefits in the crack reduction department. So something that we wanted to point out as well, well, some treatments are behaving in a similar manner after 7 years. So for example, right now, we don't see much of a difference between a double micro, a triple chip seal, or a virgin thin lay after 7 years. That's not necessarily gonna hold over time, but that's something that we can take right now and learn from that at this point. And that also brings the importance of continuing with, data collection, data analysis, monitoring the sections to learn more from them. Again, to summarize, our performance has been mainly determined in the south by cracking, and in the north, it's more of a function of IRI. Again, different conditions. We have few of the treated sections that have fallen in the poor condition category with our indicators. But even if they are in poor condition, it's still better than the control sections that was untreated. That's also in poor condition, but with much more cracking, much more rutting, higher IRI. We need to monitor everything. So not only those 3 that I've been talking about, but like I said, if we have a friction problem, then that stops everything because it's a safety issue. But we have seen life-extending benefits across the board, and that's important compared to an untreated pavement. And that's exactly what we expected, but it's exactly what we wanted to prove and measure in a more consistent and more detailed way. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.